Welcome back everyone to part 2 of our 5 video series. My name is Zani Nazmi. Thank you for staying and not running away when I scare you in the first video. I am one of the trainees for the LCOP Internet Volunteer Program, and today we are going to learn about Coding School 3. Now in my last video, we looked at our CodeWiz sensor board and went around identifying every sensor on the board and what does each part do. I also explained what a sensor board actually is, and I mentioned that in order for us to teach our sensor board to be able to detect the changes in its environment is to first teach it with some code and scripts. Today we're going to look at how to teach our sensor board with a platform called CodingSchool3. This CodingSchool3 platform is available for download for free with the description underneath this video, or you can download it from the Codable website, links here. It is a software built based on Scratch 3.0 programming language to help us communicate with our CodeWiz. Now, before I begin, I'm going to use a lot of real-life teaching analogy here today because 1, I'm a teacher, and 2, it also helped a non-programmer like me during the training to really understand what programming is all about. So, we talked about us writing codes in order to teach our sensor board to feel things. I'm going to act as if this sensor board is my student. So if you've never experienced programming like me but in some way have experience teaching a student, a younger learner, or maybe a younger sibling, this teaching analogy might help you out in understanding what coding is all about. So to start things off, we have to understand that to teach is to communicate. While teachers communicate with the students in an audible space using words, sounds, the primary way for us to communicate with our sensor board is via a USB connection with a USB cable. And of course with codes, and we are going to program those codes in our app called CodingSchool3. Alright, so the first thing you want to do is to first connect your CodeWiz with a USB cable straight up to your computer. You can hear that sound just now. And when you do, you'll notice that your CodeWiz is now lit up with this red LED and a visual on the OLED panel. This shows that your CodeWiz is perfectly working, and all I'm saying is basically this means that your CodeWiz is working just fine and you're ready to communicate with it. So in order to communicate with our CodeWiz, we need a platform or a software called CodingSchool3. So you might have to download this software first into your computer and install it. Don't worry, this takes just a while, so you can pause the video, we'll wait. And when that is ready, you have to run the software and connect to your CodeWiz, done by this button at the top over here. Alright, so if this is your first time connecting your CodeWiz to your computer, you will see a phrase underneath the CodeWiz icon that says update your firmware. So on our CodingSchool3 platform, we are also going to click on this button. Alright, just wait for 5 to 10 seconds and a pop-up should say that upload is already complete and now you're ready to communicate with your CodeWiz. Just a word of reminder here, you might have to click this connect CodeWiz button every single time you connect your CodeWiz to your computer. This is kind of like taking an attendance for your student when they first enter your class. If you don't take the attendance, you wouldn't know who's in your class. And that's teaching analogy number 1. Make sure you connect your CodeWiz. Make sure you take your student's attendance. Alright, now that that is done, we are going to understand our CodingSchool3 software layout. Now, over on the left side of the screen are our codes to help us talk to and teach our CodeWiz. These are called code blocks, and they're like jigsaw pieces or in teaching analogy, various contents and materials that teachers have to think about and select every day in order to construct their lesson plan before they start teaching. That's analogy of teaching number 2. In the middle here, this empty space is the, well, take it like it's a blank page for you to write your lesson plan. This image of a wizard here is called a sprite and is how we see our student, and the control panel here is for us to change the sprite above. So the main thing that we will be doing in our CodingSchool3 and basically to teach our CodeWiz to be able to sense, process, and react to sound, light, distance, changes in its environment is all done through this program. So, like teaching an actual student, first you have to select all the contents of your teaching, your materials, your strategy, your learning standard, your curriculum standard, all that will fit what you want your student to achieve for that day. Then you arrange it all in a lesson plan so it becomes coherent and it's a lesson that you can deliver to your student. Afterwards, you will carry out your lesson plan and see how your students react, if there's any changes and how they respond. If it's positive, that lesson plan is a go. Or if they are not responding that well, you might have to go back to your lesson plan and make some changes or improvise along the way. In the case of teaching our code whiz here, we are first identifying and selecting all the necessary code blocks required to carry out the function we want our code whiz to have. Then we arrange those code blocks to form a lesson plan. In this case, we call it a script. Then we execute it by this click of this button, and this sprite over here will give us the data or the output to tell us whether did that script actually work or not. So let's try with a simple script for our code whiz. Okay, before we start, we first have to realize what we want our code whiz to be able to do. So consider this like planning for your lesson objective. You must set your lesson objective first in order for you to construct your lesson. So in this case, it's a script objective. So let's think of it this way. By the end of this script, our code whiz should be able to detect sounds around it using its microphone. And then when the sounds gets a little too loud, detected by the microphone, the buzzer at the back will make a loud sound. So what we do, we will open our list of code blocks here, and we want to start with this code block. This when click code block is necessary to tell our code whiz only to start listening to sound around it upon our click. So consider it like setting up a classroom rule where you want your student to first raise up their hand before they start answering to your question. Then afterwards, you will select this code block, which is called forever. In computing terms, this is called a loop. What a loop is that we want our sensorboard to, upon click, continue sensing that change in sound around it with its mic indefinitely until we finally tell it to stop. So consider this forever code block as sort of like asking your student an open-ended question. You would want them to respond continuously until we tell them to stop. Then inside this forever loop, we would also want this code block, which is called if then else. This if then else call is called conditioning, and consider it as a very clear objective or conditional task that we want our students to complete and remember by the end of this lesson plan. So let's use the word if then else in order to truly understand how this code block works. So let's say if you want to teach your student or you want to advise your student something, you would say something like, if it is raining, then you should stay inside, or else you can go out and play. Alright, the phrase if it is raining is an input or a condition that our student need to take in and understand. You should stay inside is technically the first output if the first condition is met. So if it is raining, then the student should stay inside. Finally, that or else you can go out and play is considered as an alternative output. Basically, if the day is raining, the student should stay inside. Or else, if the day is not raining, then the students can go out and play. So remember, input, code, output. So if you remove the phrases just now and replace it with technically a sentence in order to teach our code whiz, we would have something like, if it is loud, then you should say beep, or else just sit there quietly. Now that we have these phrases, basically we have to represent these phrases with a particular code block. So that phrase, it is loud, requires this code block over here. And now I'm going to drag it and put it on the blank page. So Loudness is of course subjective to a sensor board, so you might have to be a bit more specific with how loud is loud. So you might want to change this value to, for say, 100. Alright, next. Then you need to say beep. So the phrase you need to say beep is represented by this code block, and we're going to pull it into our blank page. Finally, the last phrase, or else just sit there quietly, is represented by this code block. Alright, now these code blocks are all over the place. It's not in a proper script yet, and we have to arrange it from top to bottom. So much like our lesson plans, the script will be read or run from top all the way to the bottom. So in this case, we want our code whiz to only start running the script when we click it. So this goes all the way up. We want it to run the script over and over until we tell it to stop. So this goes next. And then what we want to run forever? Well, basically we want this if then else code block to be in the center. If you click on this code block, basically this will allow our sprite to visualize what kind of data or what kind of input it is taking in. So you will see this value over here. Just give it a quick check, make sure that every code block is now connected, and then you are ready to click this green flag button to start our script. This is actually how loud the sound is being detected by our sensor board's microphone. So for example, if I make a loud sound here, so you should be able to hear that beep just now. This means that this code is running perfectly. So you can see that whenever my voice is loud enough, the visualizer will reach 100 and the beep sound will be produced by the buzzer. Unfortunately, you have to understand that unlike our students, where they are able to understand and memorize one knowledge over the other over a course of 2 or 3 lessons, like what you're doing with this video right now, our code whiz is only able to understand one lesson in one particular time. So in other words, when you delete out this script from your coding school tree, it means that the code whiz will also forget that script and now back to its original senseless status. While this may seem like a bummer, know that while code whiz can only learn one lesson at or one script at a time, it can be a very long script with multiple if then else conditions. For the sample that we use here, there was only one if then else condition. For a longer script, we can have more than if then else code blocks, so it takes in more than just one input. Point is, there's some difference in learning between your student and the code whiz, and all you have to do is differentiate. Now that's a teaching analogy. So there you have it. You wrote your first script and the first lesson you have taught your code whiz. Check out the description below this video for more scripts so you can teach your code whiz to be able to sense more than just sounds, but also temperature, distance, level of orientation, and many more. You realize that each script runs a specific function of if then else. But in our next video, we will start with our STEM projects, and this STEM project will combine if then else code block so it can serve a more advanced purpose. Until then, I'll see you in the next video. Bye bye.